All right, so we're going there. Wow, we're missing a lot of students, missing the class before the test. That's really terrible, terrible, bad habit. So if you're hearing this later, watching this Zoom after the fact, and you missed this class, that's a bad decision. Okay. But be that as it may, for you guys who are here, we are going to talk a little bit about the things that are on the test, in particular the sample test, a little bit later on. But now remember, of course, the format of the test, right? The protocol for the test. So if you are A through M, if that is where your last name begins, right, then come at 10, right? And you'll take the first half of the period and to take the test. And then for the remainder of you guys, what's the rest of that, N through Z or something? You guys come in at around 11:15, all right? And then we'll start either at 11:15 or shortly after that. And then you'll take the test, right? Okay, in that time frame. So, and the test will be set up right that you'll be able to finish in that amount of time. So don't start sweating about the length of the test. Okay, just worry about the preparations for the test, right? So, filling out your survival card, make sure you show up with something to write within your calculator, right? Okay, you'll almost certainly need a calculator, and your survivor card filled out, right? Okay, and then of course make sure you prepared for the test right by finishing your homeworks. You've got 2 homeworks due. Well, a homework that's important, that's due at the time of the test, that homework on angle measure, right? So make sure you've done that before you come to take the test, because that material is on the test, right? Okay, and so this homework is not due at midnight, it's due at the time of the test. So think of, I got to finish this by midnight Sunday or something, right? Instead of 10 on Monday morning. And then of course that algebra review, right, which can include which you get extra credit, $5 extra credit, right, if you finish 80% of that. I posted a new homework here on this is about trigonometry of right triangles. So we've been we've already finished that discussion. That's not on the test, however, right? So there are problems on the sample test about the trigonometry of right triangles, but we'll save those for test number 2. Okay, but anyway, that homework is posted now. So and you're ready to work on that. That's about solving triangles. So we've seen plenty of examples of that. That's going to be our recall practice for today when we finally get to the notes here in a second. Oh, now one thing I keep forgetting to say. But remember this, right? Of course, you want to pass the test, right? Okay, for the sake of your ultimate letter grade at the end of the semester. But beyond that, for you guys who have been attending online, you need to pass the test, because if you don't, you cannot continue online. You'll have to come to class, right? Okay, so that's the rule that was in the syllabus, right? This is really not an online class. So you need to prepare well for the test, right? If you want to continue attending on Zoom. But if you don't pass the test, I'm going to assume that the Zoom is not working for you, right? And so you need to be in class with me and the other students, and so you'll have to start coming to class, right? Okay, so keep that in mind as just another. If you're really liking attending on Zoom, it's just as another incentive to prepare well for the first test, right? Okay, so don't forget about that. Do y'all have any questions about the test? I'm going to look at a couple of problems from the homework, and then we have a recall practice that we're going to do, which I just mentioned is about solving triangles, so that's really easy. And before we launch into finishing the notes that we were looking at last time, and then we'll look at some problems from the sample test, just some things that I wanted to point out maybe from the sample test about the, that for you to keep in mind when you come to take the test. But do you guys have questions? So the participation in the homework has been good. Okay. I think sometimes the scores could be higher, so should be working on raising your homework scores. But for some of you, you're not really participating in the homework very well. So you've really got to, work on your homeworks, right? There's not going to be any other way to pass the class. It's not just because it's a percentage of the grade. It's just that you won't be able to prepare well enough for the test without doing the homework. Right. So for you guys who are really not keeping up with the homework very well, you really cannot continue that habit, right? That's not going to work. Yeah, Emil.
I do have a question about the after the 50 exam, still stay for the class.
Well, because we have other people coming at 11:15. If you're in the first group, are you in the first group? I can't remember your last name. So yeah, you'll have to stay till 11:15. Yeah, unfortunately. Okay. So, but you're not going to finish too much before 11:15, so it's not like you're burning that much time. Well, maybe I don't think it's like fast, but so bring something. Maybe work on one of the other classes until 11:15. Yeah, I have to hold you hostage until 11:15. If you're in the second group, though, once you're through, you're free to leave. Yeah.
When it comes to this, we have to.
No, you don't. No, that you wouldn't bring on that you wouldn't bring on the test. You mean, do you want to put something like that on your survival card? You really won't need that for this test. Okay, because this test only goes through angle measure, and those are trigonometry sorts of things.
Test 2, we don't bring them as well.
Yeah, you can't bring the whole sheet, right? Okay, so you have to figure out how to put on the index card what you need, right? Okay. So I already gave you I already discussed a trick there for remembering that table, or parts of the table, not the whole table, because that's a lot, but remembering parts of the table, right, without having it in front of you, right? Yeah, son. Yeah, you can write on front and back, right? As long as it's a standard size index card. Okay, so yeah. So it can't be oversized. Yeah, that's a standard size. It's something you can purchase, then it's a standard size. Yeah. Right, but it gotta be an index card, right? So I don't want you to bring like a poster sheet.
Yeah, like something like this, right?
Huh?
That's something like an index card like this.
No, that's fine. That's a standard size index card.
That's a simple size.
Yeah, because you can buy that, right? Store. Yeah. Right. Okay. So all right. There are 3 standard sizes of index cards, as far as I'm aware. I think the small one is 3x5, and then there's 4x6, and then there's 5x7. That may be 5x7. So you can take that. I mean, you can bring. Okay. Yeah. All right. But so spend some time thinking of what you want to put on your index card. That serves 2 purposes. Of course, it helps you on the test, but just the very process of figuring out what you need to put on the index card really helps you study. Okay, so that helps you sort of review everything that we've done so far, because you have to think about that, right, in order to write stuff down on the card. Okay, so it works a couple of ways to help you do better on it.
I have a question.
Yes, sir. Who is it, Fernando?
Ishan.
Ishan. Okay, Ishan. Yeah.
Yeah. Is there any limitations on what calculators you can bring? Like, can we bring a TI-84 calculators and that's fine, right?
Is there any sort of calculator is fine?
Okay, perfect. Thank you.
Yeah, any sort of calculator is fine. But yeah, any sort. But now, well, of course, just a simple 4-function calculator may work for this test, but for the second test, you'll need a scientific calculator. But any sort of scientific calculator is okay.
Okay, perfect.
Yeah, Christopher, you can bring 5x7 because Ishan, the way the questions are designed, the calculator can help you with computations, which is what calculators are supposed to do. But you really won't be able to use the calculator for other things. The way I write questions, and remember, you have to show your work also, right, Ishan?
Yeah.
Okay, so I'm not concerned with the style of the calculator in the sense of it being too much benefit to you. Okay. All right. Good questions. Any other questions like that?
What if we don't have a calculator?
Oh, you need to bring a calculator, right? So you have to get your hands on some sort of calculator. But well, a scientific calculator, some type, right? Yeah, because I won't let you, yeah, I don't let you use your phone, right? So no phones. So yeah, I do draw the line at phones, so no phones. But you can get at least you used to be able to at a dollar store, you could get a scientific calculator really cheap. Right. So or just borrow one, you know. Does not have to be a graphing calculator. Although there is graphing on the test that you will do by hand. Okay, so all right. Yeah, Christopher, 5x7 is fine. Standard size index card. All right, let me open up the functions review. There's one problem on there that I have had several questions about. I'm not surprised. Should have mentioned it before. And this one is due this evening, right? So it's the last one. So there you have a piecewise function because it's got those three separate pieces in it, right? So that's a piecewise function, and formulas for piecewise functions are going to have different formulas for the different pieces. So you end up with kind of a complicated looking formula like this one, where you have to fill in different formulas for the different pieces in the graph, right? Okay, so that's what we're trying to do here. I think in class, we sort of did the opposite problem. We started with a piecewise function formula and we drew the graph. This is backwards. They're giving you the graph and they want you to fill in the formula for the piecewise function, right? So parts of the formula they have filled in, this first piece, right? That piece extends up to -1 on the x-axis. So they're telling you here, right, that the domain of this first piece is numbers less than or equal to -1. And then the second piece extends from -1 over to 2. So the domain for the second piece is numbers from -1 to 2. And then the domain for the third piece here, since it starts at +2, the domain for that piece is numbers bigger than 2, right? Okay, so that part of the formula they have filled in. You have to know in a piecewise function when to use which formula, right? Because you've got multiple formulas to choose from. And it's this domain information on the right-hand side that sort of gives you that recipe for knowing, right, which formula you want to use when you're evaluating an input. So if you pick an x value that's less than or equal to -1, right? Pick an x value less than or equal to -1, then you would choose this formula to do the evaluation. If you pick a number between an x value between -1 and 2, you would use this formula to do the evaluation and so forth, right? But now what we actually have to do is fill in the formulas. So we have to figure out what is the formula that corresponds to this piece, what's the formula that corresponds to the second piece, and what's the formula that corresponds to the third piece, right? But we get a little bit of a break here because all of these pieces are lines. So this is really just a question about writing down the formulas for 3 lines, okay? So that's all it is. You have to write down the formula for this line, you have to write down the formula for this line, and you have to write down the formula for this line, and just put the formula right here in the box, okay? So well, let's do that. Well, let's do the middle piece since that's, well, no, let's go ahead and start with the piece on the left there. So that is a horizontal line, and you might remember, but if you don't remember, that's okay. So let's see, that is a horizontal line that stretches across y equals 4 here, right? So when I switch to my notes here, I want to remember that. This is another problem that we're going to look at in just a second that I drew a picture of. Let me add some paper here. There's our recall practice. Okay, so there's some blank paper, right? So we had that horizontal line, right, that was at y equals 4, right? All the y coordinates were 4. So you might recall that one thing that's easy to remember, but if you don't recall it, that's okay. You might recall that for horizontal lines, they always have, their formula always has a very simple form. It's always y equals some constant, all right? But in this case, that constant is going to be 4, correct? Because along that line on the left-hand side, the y coordinates of all those points was 4, right? Okay, so the formula for that line is very easy. It's just y equal to 4. Okay, so so back there in the answer space, what you want to fill in there is just the 4 right here. Okay, you don't type the y equal, because f of x is the same as y. So that part of the formula is already included, right? Okay, so you just type here 4, right? So you get a very simple formula for the first piece. It's just constant 4, okay? Now, if you didn't remember that, okay, though, that for horizontal lines, formulas for horizontal lines are always y equal to a constant, then you could just go through the whole process of finding the formula for that horizontal line, right? Which means you have to find first, it's what? Begins with an S. Slope, right? You have to find the slope, correct? And to find the slope, you have to know what? What do you need to calculate slope? What's in the slope formula? X and Y coordinates for how many points? 2 points, right? So you need the X and Y coordinates for 2 points. In other words, you need to know 2 points on the line, right? Okay. Or sometimes you're given some other information that you might use to figure out what the slope is, but generally you need to know 2 points on the line. So it's easy to identify points on this line on the left-hand side, though, right? For instance, minus 5, 4 is going to be on that line, correct? And also minus 2, 4 is going to be on that line. So you can pick off those 2 points, or you can pick off any other 2 points that you want here and calculate the slope. So so let's do that. Let's see, I said we were going to use the points, what, minus 5, 4 and minus 2, 4, but you could have used other points, correct? And then when you calculate the slope, you get what? 4 minus 4, right? The difference in the y coordinates divided by the difference in the x coordinates, right? That's going to be minus 2 minus a minus 5. So in the denominator, you get minus 2 plus 5, which actually turns out to be 3, but the 3 is kind of meaningless because the numerator is 0, so all this is going to reduce to what? 0, right? Okay, so you get a slope of 0. And now you can just use your, remember, now that you know the slope and you know a point on the line, you can use your point slope form. So what does the point slope form look like? It's y equal slope, right, times x minus x coordinate of one of the points that you're given. Let's use this point. So we have x minus a minus 5, and then just add on the y coordinate of the point that you're given, which in this case is 4. Well, look what happens here, of course. Since the slope is 0, and you multiply this set of parentheses by 0, you get 0, right? And all that just boils down to what we started with before, right? Which is y equals 4. Okay, so there's two ways of seeing, right, that the equation for that first part is y equals 4. Now the second part's more interesting, right? Because that's not a horizontal line. Oh, what's the formula for this part then? The part on the far right. Y equals what? Is it 1? Oh yeah, 1. Okay, I thought it was 2. All right, but y equals 1. Yeah, you're right. Okay. So y equals 1. So you can just fill in a 1 here. You don't need the y equal again because the f of x is the same as y equals. So so now let's fill in the formula for the middle piece. So there we don't have a 0 slope, so we actually are going to have to calculate the slope here, correct, right? So we need a couple of points on the line. I guess this one's obvious, right? 0 and 4, the y-intercept there is 4. And then this one, 2 and 2, right? So, but you could use 2 other points. So, so let's write that down. Let's see, we have the points 0 and 4 and 2 and 2. And now calculate the slope of that line. So I have 2 minus 4, the difference in the y coordinates, right, over 2 minus 0. So we get a really nice slope here, minus 2 over 2, which is -1. And that's all you need. Now just fill in the point slope formula. So you get y equals -1, the slope, right, times x minus the x coordinate of one of your points. Let's use this one since it's 0, x minus 0, and then just add on the y coordinate here, which is 4. So you get what y equals minus x plus 4. And I think the answer in WebAssign is 4 minus x, which is the same thing. Okay, they just reverse the terms there. If you didn't want to use point slope form here, you could have jumped immediately to this expression, because remember, you know here the y-intercept is 4 because that was in the picture, right? The y-intercept was 4. So you could have written down your equation for your line in slope-intercept form in this case. The slope is -1, the y-intercept is 4, so you just write minus x plus 4, right? So you could have skipped this and immediately down minus x plus 4, but it doesn't matter, right? They're the same, okay? So there it is. So there's what the formula is. 4 minus x goes into that second, 4 minus x goes into that second, or minus x plus 4 will work also in that second box. Jakayla. I entered all these previously and it didn't accept it for some reason. Yeah, I wonder why. Okay, so there's got to be some sort of weird typing thing here. Let's see, let's try it. So see what I get. See if I can get my keyboard up here. So I said this was what, 4, right? And this one was 4 minus x. 4 minus x. And then this one was 1. I can submit that. Is there any other parts of that question?
Yeah, I saw my issue. I put y is equal to y is equal to y is equal to whenever y is equal already there.
Yeah, I know. I knew that was going to be a problem. That's why I was trying to point out that you already really have in the answer f of x equals, but f of x is the same as y. Remember, in function notation, f of x means y. Okay,
Yeah.
so you didn't have to type y equals y equals y equals. For fun, let's just submit that. I'll get some points here on my homework, which I rarely have. There it is. Okay, so right. Right, so I think that I hope that makes that a little bit hope that makes that a little bit clearer. Let me now skip to the homework that has not been due yet. So I don't know how far y'all into this homework on angle measure. This homework, but again, this is due at the test, right? Because this is going to be on the test. So you can look at the sample test, right, and see that there's problems like problems on this homework. Don't forget the it's easy to forget the these two formulas, right? The arc length formula and the area of a circular sector formula. So we did a couple of examples with those. Don't forget those formulas. There's a couple of problems from the sample test about using those formulas. And actually, I want to look at a problem I think that uses those formulas. All right, it's this one. Okay, this is all stated verbally, so and so it's kind of hard to follow it because it's all stated just in words, and it really helps to draw a picture. So that's what I did, draw a picture here. But I have slightly different cities in my picture, so I'll have to alter them to fit this this version of the problem. All right, so St. Louis, Missouri, and New Orleans, they lie approximately on the same meridian. All right, so meridian for longitude and latitude, right? Okay. So that means that St. Louis is directly north of Orleans, almost directly north of Orleans. And St. Louis has a latitude of 39 degrees north. And New Orleans, though, has a latitude of just 30 degrees north. And we want to find the distance between the two cities, okay? So just based on their latitude, what's the distance of the cities? But they do have to tell you the radius of the Earth is approximately 3,960 miles, okay? All right, so here's what they're talking about. Let me switch back to the notes, and then let me redraw my, slightly redraw my notes here. because the version of the problem that I had here before involved not St. Louis, but Memphis. So let me erase Memphis here, put in instead St. Louis. Okay, so here's St. Louis on the, so this this sphere here is the Earth, okay? So imagine that's the Earth. And so the latitude of New Orleans, okay? So what that means is this angle between the equator and New Orleans is approximately 30 degrees. All right, okay. And however, St. Louis, on the other hand, is a little bit further north, okay? So its latitude is 39 degrees, all right? But they're on the same meridian, all right? So in other words, St. Louis is exactly due north of New Orleans. So meridian would be a circle like this one, right, around the globe, okay? But this is a circle of maximum diameter, right, around the globe, like the equator is, okay? So so both of these cities lie on approximately the same circle, okay? All right. And what we want to figure out is, what is this distance? So if you just take that that meridian, right, and cut it as a cross section and lay it down flat, you're going to get a picture that looks like this, right? Okay, except the cities are slightly different. So what I've done is taken this meridian, the meridian that these two the cities lay on, right, and I sort of extracted that and then just laid it flat here. Okay, so of course that's going to give you this circle, right? And here's St. Louis. For here, and there's New Orleans, of course. And what's this angle now that's going to be between these two cities? Well, remember, New Orleans is at 30 degrees latitude and St. Louis is at 39 degrees latitude. So this angle between the two cities would be what?
9 degrees.
9 degrees, right? Okay. So in this picture, right, this angle that's has its vertex at the center there, that angle is right 10 here. This angle is 9 degrees. Okay. And with that information now, you now can calculate the distance between New Orleans and St. Louis, right? You can find the length of this arc using this arc length formula, right? Okay, which says that the length of this arc, which the book usually labels arc length as S, is going to be the radius times this angle, right? But this angle must be in radians. So that's the one catch. So don't use degrees there, right? You've got to convert that to radians. All right, so let's do the calculations here. So we know S is going to be the radius, which is what? 3960, correct, right? Okay, times, and then our angle, but let's convert that angle from degrees to radians. So how do we convert that to radians? What do you multiply by? What? Pi over 180, right? Okay, so we'll take the 9 and multiply it by pi over 180. That will convert it to radians, and then we just multiply that times the 3960. Okay, and now of course you'll need a calculator to help you do these computations, right? Okay, well, some of them are you can do a little bit of. 9 goes into 180 20 times, right? So you could simplify that without a calculator. So you really have 3960 times pi over 20, right? What is that approximately? Can y'all do that for me? So 3960 times pi and then divide by 20. So make sure on the test you can do calculations with pi, right? If you have to, you can approximate pi as approximately 3.14, right? But most calculators will have pi on them. Y'all are slow. What's wrong? Will someone do that? What now? 622. Is that rounded to the nearest? That's the nearest mile? Okay, did y'all get something like that at home? 622? Oh, that sounds about right. You should Google that and see if that's correct. What's the distance between New Orleans and St. Louis? Okay, sounds like that could be correct. I'm not sure how accurate. I'm not sure how accurate the Rebbesign problems are. So, what now? $677. Oh, okay, well, we missed a little bit there, but probably those latitudes are not exact, and probably St. Louis is not due north of New Orleans. Oh, that's a, oh, I see. That's a driving route. Yeah, I see. Okay, well, that's probably will add a little distance too, right? So, okay. Now, there's another problem on here. That one is fun as well. All right. So, let's read this one. I'm not going to go through the whole problem. I don't have a picture of this one in the notes, but we'll do a little bit of it. Let me move y'all around. Okay. So a cow is tethered to a rope, like you see in this picture, but the rope is tied to the corner of this L-shaped barn or something, right? And like you see in this picture. And now we want to keep the cow alive, right? So the cow has to have a sufficient area to graze, okay? And so that's what we're interested in computing here is in what is the area, a square, I guess it's going to be feet because all those units of measure are given in feet, right? So what's the square footage that cow can graze, right? Tethered to the rope as in this picture. And they're going to give you the dimensions of that building, right? And you also know, they told you the length of the rope, right? What was 120 feet, okay? And they're going to give you the dimensions of the building. So this side A that they've labeled A on the barn is, what's that? This is 30 feet. And this is more, that's 60 feet. That's not, doesn't look drawn to scale, right? And of course, the length of the rope is 120 feet. This distance is 70 feet. And then this distance here is 60 feet, okay? And so again, we want to calculate what's the square footage that the cow can graze from, right, in this picture. So if you think of the cow, you know, walking around, right, in the yard there, in that field, right, tethered to that rope, okay, obviously this big quarter, right, okay, this big section of the yard, the cow can graze, right, okay, so this would be the portion where the rope is vertical in this picture, right, and the cow's that has the rope taut, right, so the cow's the furthest distance, or where the rope is horizontal, correct, okay, and again the cow's at the furthest distance. So that would be the sort of the boundaries for this portion that the cow can graze. All right, so we're interested in what's this what's the area of this piece here, right, between the dotted lines. Okay. Well, that's pretty easy to calculate, right, just using our circular sector area formula, okay, because this a region, right, between the dotted lines is going to be a portion of a circle, right? That would be the portion of the circle, if the cow could walk all the way around here from the center, correct, okay, which the cow cannot, but nevertheless, if the cow could, this portion, right, of the this portion of the field here would be a sector of that bigger circle. So let's see, what's our circle sector formula? Y'all recall that? The area is, it's 1/2 times the radius squared times the angle. Okay, the angle that forms the sector. All right, so it's 1/2 r squared theta. All right. Let's put that down then. So let me find the notes. Scroll down. All right, that's right here. So the area is, in general, for a circular sector is 1/2 r squared theta. So in that, for that particular sector though, for that particular sector, the area is going to be 1/2. What's the radius? So again, remember, you're thinking of radius of a circle. You would think of the circle all the way around the building, right, where this is the center. So think of the cow, you know, walking at maximum distance all the way around the center here, that circle, right? So what's its radius? 120, right? It's the length of the rope, correct, right? Okay, it's the length of the rope. And then what's the angle here for this sector? That's pretty easy though. No, for this whole sector. No. 90, right? Okay, about 90. Yeah, you're looking at the way they draw the picture here, but for this whole sector, this angle is 90 degrees. But remember, you have to express that in radians, though. Okay, you have to express that in radians. So in radians, that's going to be what? Pi over 2. So multiply there by pi over 2, and that's going to be the area of that sort of biggest part, right? That the cow can graze from. Let's call that a sub 1 because I have several areas here. This is only one of them. So can someone do those calculations for me? Just approximately. And the nearest square foot will do, because we're not gonna write the whole answer. Someone on Zoom can do this also and type it in for me. All I want is the nearest, just the nearest square foot, right? This is going to be square feet, correct? Because this is an area. So 1/2 times 120 squared times pi over 2. Approximately what's that equal to? Come on, guys, someone, you know, I'm gonna be here all day doing this simple calculation. Y'all are gonna be that slow on the test that you'll never finish. Someone on Zoom, calculate that for me. Did y'all get the same thing here? 11,309 approximately. So we can round that up to say 11,310. All right, thanks. Right, 11,310 if we round to the nearest square foot there. All right, now so that's the easy one to understand, right? So 11,310 is part of that total area, but it gets a little bit more complicated, right? Okay, so let's look at one of the regions that the cow can graze. That's a little bit more complicated. What about this piece? Okay, so cow can graze from. Now, how does the cow get to that piece? What's the cow going to have to do? Yeah, he's going to walk over there, right? Okay, but when he walks over there, how far can he get into this piece? Well, that would be what if the rope were completely along the side of this, or tied along the side of this building, right? I mean, along this side, right? And then also tied along this side, right? Okay. And then he would have some free rope left, right, to roam around in here. But how much rope is left? Is it 30? Right, okay, because this part was 60. right? This length is 60, this length is 30. So 90 feet of the rope has been used, right? Okay, and he has 30 feet at play there, right, to roam around this piece. So, and when you're calculating the area here, you still have a circular sector, right? Okay, right, but the radius has become what? Shorter. What, Emil, has the radius become? See, the rope is tight here and tight here. So that uses up 90 feet of the rope. So what's left here for the radius? What now? Yeah, 30, right? Yeah, 30 feet left, correct, right? So you have portion of a circle, right? If you draw the whole circle, it would look, something like this, correct? Okay. But you have a portion of that circle, right? And what's the angle of that sector? So what's the angle of this sector here? Still 90, right? Still pi over 2, right? Okay, except the radius now is 30. So you can calculate that area very similar to the other one, right? Okay, you're just changing the radius, correct? So let's call that area 2. So that's 1/2 times 30 squared, right? Times again pi over 2. And just compute that, get a decimal, get an approximation. And that becomes another area, right, that the cow can graze in. So to get the total, you would have to add these two together plus a few more. So what are the other places that the cow can, what are the other places there that the cow can get to, obviously? Well, there's this big piece here, right? That's a circular sector. What's the radius of that circle? That corresponds to this section. 60, right? Okay, because I think of to get to this piece, right? The cow's gonna, the rope is gonna be tight around along B, right? Along this side, leaving 60 feet left, correct? So you've got that piece. Where's the other piece? Down here? Yeah, what's the radius there? 50, right? Okay, because this length is 70, so you have 50 feet of free rope there, right, to roam around in this sector, correct? Okay, so that's 1/4 of a circle with radius 50. Okay. So just calculate those 4 areas and add them up, and that's it. Okay, that would total. That would be total square footage. All right. So when you get to those, you get to those problems on angle measure, right? Those you'll be able to do. Okay. All right, so before we go back and look at some of the things from the sample test, let's do a little bit of our notes, all right? And then towards the end of the class, we'll look at some things from some things that are on the sample test, which are also similar to homework problems, of course, okay, throughout all the homeworks that you've been doing through the semester. Okay, so I mentioned this at the end of class last time. So far, we've just been able to compute the trig ratios for acute angles. So that's angles between 0 and 90 degrees, between 0 and pi over 2, okay? But we're gonna have reason to be able to compute trig ratios for larger angles and also negative angles as well, right? So we actually want to be able to compute the trig ratios for angles of any size, okay? No matter how large or even negative angles. Remember, we can draw negative angles. So we want to be able to also compute trig ratios for these negative angles as well. So the question is, how do we do that? Because you cannot embed a negative angle in a right triangle, right? Okay. Or you cannot embed an angle larger than 90 degrees in a right triangle. But our definitions for the trig ratios are all based on sides of a right triangle. So how do we define sine and cosine and tangent and so forth, right? For angles that are bigger than 90 degrees or for negative angles. All right, so that's what we're going to do today, okay? I'll show you how that's done. All right, so I'm going to start with a really simple picture. And let's imagine that we have an angle theta, okay? And let's start with theta being an acute angle, so between 0 and 90 degrees. So we're really not adding to our knowledge yet here, okay? But then this diagram, I'm gonna draw the diagram in a different way in next here. All right, so here's this angle theta. It's an acute angle, so it's between 0 and 90 degrees. I don't know how big it is, right? And notice I've drawn this in standard position. So in standard position means, you know, the initial side of the angle is along the x-axis, right? And then the terminal side of the angle is somewhere else, correct? In this case, it's in the first quadrant because this angle is between 0 and 90 degrees. Now, along the terminal side of that angle, I'm going to pick out a point, any point that I like, okay? On the terminal side of that angle, I'm going to pick out a point. So I could pick out a point way over here if I wanted to, or I could pick a point really close to the origin if I wanted to, right? I'm just going to pick out some point on the terminal side of that angle. Of course, that point has coordinates, right? Okay, so here are its two coordinates. I'm just going to call them x and y. I really don't know what those numbers are because I picked, this is any point on the terminal side, okay? So any point whatsoever. And of course, that point has a distance away from the, origin, right? Okay, so I'm calling that distance r in this picture. Well, look now, it's very easy here to, once you pick this point, you can superimpose a right triangle in this picture, right? Okay, so you can draw a vertical line down from the point, okay? And then of course you have the x-axis here as a horizontal line. So you have a right triangle here, right? Here are the two sides of the right triangle, this vertical line that I, plus this portion of the x-axis. And then of course the hypotenuse is this line from the origin up to the point that you chose, right? Okay. Now, what's that distance? So what's the length of the hypotenuse here of this right triangle? In other words, what's this distance away from up to this point? Well, of course, the Pythagorean theorem says, r squared is going to be x squared plus y squared, right? Which means that r itself is going to be the square root of x squared plus y squared. So it's easy to calculate this. It's easy to calculate this distance, right? It's just the square root of, it's just the square root of the square of the coordinates of the 2 points. Now, notice with that picture, then it's very easy to compute all of your trig ratios, right? Very easy to compute your trig ratios. What's the sine of theta going to be? The sine of theta. Y over r, right? Okay, or y over the square root of x squared plus y squared if you want to write down the formula for r, right? What's the cosine of r going to be? I mean, of theta going to be? X over r. What's the tangent going to be? Y over x, right? Okay, so from this picture, you can define the trig ratios in terms of the coordinates of this point. Okay, that's the reason of drawing this picture. Okay, the trig ratios can be determined just from the coordinates of this point. Okay, and this point, remember, is any point on the terminal side of the angle. So there they are. Okay, right. So if you have an angle and you put it in standard position, right? Okay, and this is a point on the terminal side of the angle, right? Any point on the terminal side of the angle, then you can compute the trig ratios, right? For that angle, just using the coordinates of the. So as you told me there, Robbie, a sine is going to be y over r, and remember r is the square root of x squared plus y squared, right? Okay. Right, there's cosine x over r, there's tangent y over x, and then of course just take the reciprocals to get the other 3 trig ratios, right? One thing it's really important here, I want to point out is, look, r is this positive square root, so r is always positive, right? Okay, so notice the sine of theta, whether it's positive or negative, depends on the y value, right? Okay, because this is always positive. The cosine depends on the x, the sine of the x value, because the r is always positive. All right. That's just something to keep in mind. Now, so far, none of this is anything new, okay? Because, you know, we had an acute angle here, and I still was using a right triangle. So all of this is, you know, just, I'm just kind of rewriting what we already knew. This is, I haven't really added to my knowledge at all. Oh, one thing I do want to point out, though, is really important is this point on the terminal side can be any point at all. So I could have chosen the point way over here, as I mentioned earlier, right? I could have chosen my point way over here instead of here. Why does it not matter where you choose that point? Because when you draw the right triangle, this right triangle and this right triangle, what's their relationship? They're similar, right? Okay, so no matter where you put this point on the terminal side and you draw this right triangle, you're going to get similar right triangles. So that means that the ratios of sides are always the same. Well, that's how we form the trig ratios. They're just ratios of sides of a triangle. Okay, so it doesn't matter, and this is really useful. It doesn't matter where that point is chosen on the terminal side. Okay, now so far this is nothing new, but now look what I'm going to do. I'm going to, in the same picture, I'm going to draw an angle, but now I'm going to make the angle not acute anymore. Okay, so look at this angle theta, all right? So that's bigger than 90 degrees, right? That's somewhere over in the second quadrant. So how big is theta? Somewhere between what and what? Somewhere between what? 90 and what? 180, yeah, okay. So in other words, it's an obtuse angle, okay? And so that angle theta cannot be put into a right triangle, all right? Okay, so you cannot put theta into a right triangle, but you can still put it in this picture. You can still put it in this picture. So it has the initial side is the x-axis, and it has this terminal side here, all right? So what we're going to do is the same thing we did in the previous picture. You're going to pick a point on the terminal side. Okay, any point you want on the terminal side. Okay, and now here's how you define the trig ratios for the angle theta. Okay, the sine is going to be y divided by r. What's the r? It's the square root of x squared plus y squared, just like that. All right. What's the cosine of theta going to be? It's going to be x. The x coordinate is point divided. What's the tangent going to be? It's going to be the y coordinate of this point divided by the x coordinate. And see, that scheme works no matter how big the angle is, all right, or how small the angle is. You can do the same thing for negative angles. So here's a negative angle. What's the size of this negative angle? It's going to be between what? 0 and, right, if it was all the way down to here, what would that be? What?
Negative 90.
Negative 90, right? Okay, if I'm drawing it this direction, it's negative, right? In the positive direction, it's 270, but in this direction, it's minus 90. So here's an angle between 0 and minus 90 degrees. Okay, we can still define the sine and cosine for that angle as well. Okay, using the same scheme. All right, so you draw the angle in standard position. There's the terminal side. Pick a point on the terminal side, any point you want. So it can be way down here, it can be way up here. Pick a point on the terminal side, okay, and then here's how you compute the sine. It's just going to be the y coordinate of this point divided by this value r, which is the square root of x squared plus y squared. Also the same as the distance of the point from the origin. It's this distance. How do you define the cosine for this angle? It's x divided by r. It's the x coordinate of this point divided by r. The tangent, it's the y coordinate divided by x coordinate. And since you can draw any angle at all in standard position, you can define trig ratios now for any size angle. Okay, just using this scheme. So let's remind ourselves what the scheme is. So we want to compute the trig ratios for some angle theta. So what do? I take theta and first I draw it what? And standard position. This is called drawing it in standard position, right? Where the initial side is the x-axis, all right? So draw it in standard position. Then what do? You pick a point on the what? On what's this called? There's the initial side. What's that called? The terminal side. Yeah. You go to the terminal side of the angle and you pick a point off of the terminal side, right? Okay. And it can be any point at all, right? So you just got to find some point on the terminal side, okay? And then now you know how to compute the trig ratios, right? The sign is going to be the y coordinate of the point, the y coordinate of the point. So remember, sine is associated with y coordinate. The y coordinate of the point divided by what's the r again? Robbie, you were just saying it. What it's the it's the square root of the x squared and y squared. In other words, it's the distance of that point you picked away from the orange. Okay, and then the cosine is the x coordinate. So remember, cosine is associated with the x-axis, associated with the x coordinate divided by this distance, and then the tangent is the y coordinate divided by the x coordinate. And then for the other trig ratios, you just take the reciprocals, just like we did. Now, the tricky part of this scheme, of course, is picking the point on the terminal side. You know, that seems like that's not always going to be easy, right? Let's practice that a little bit. But before I do that, before we practice it, I want y'all just to tell me some signs, okay? So if I have an angle, and it when I draw it, it ends up with the terminal side in the second quadrant. So that I would say the angle is in the second quadrant in that case. All right, that really means the terminal side is in the second quadrant. So in other words, if you have an angle between 90 and 180 degrees, right? Pi over 2 and pi, then what are the signs of the trig ratio is going to be? Not the value of the trig ratio, but just what about the signs of the trig ratio? Plus or minus is what okay. So what's sign going to be for an angle in the second quadrant? You know the denominator here is the distance, so it's always what? Positive, right? So you know the denominator has to be positive because it's a distance. So that's meaningless. That's right. Sine is going to be the y coordinate divided by that distance, right? But in the second quadrant, are your y coordinates positive or are they negative? They're positive, right? Because that's above the x-axis, right? So you get plus over plus, which is plus. So in the second quadrant, you know, angles in the second quadrant, their sign is positive. What about cosine? See, the bottom is always positive, right? The top is negative, correct, okay? Because in the second quadrant, you're in the negative portion of the x-axis, right? So the x coordinate, whatever it is, divided by this positive value r is going to turn out being negative. What about tangent in this quadrant, second quadrant? The y is positive or negative? Here. Positive. The x is what? Negative. Remember, tangent is y divided by x. Y divided by x. So that comes out to be negative. So in the second quadrant, no matter what the size of the angle is, right, the sine is positive, the cosine is negative, and the tangent is negative. What about in the third quadrant? Let's put an angle in the third quadrant. Here's a picture of an angle in the third quadrant. This is a really big angle, okay, because it already has one full revolution in it. So you know it's more than 360 degrees, right? And then it's got another partial revolution in it that moves it over here into the third quadrant. But we can still compute sine and cosine and tangent, etc., for that angle because we just pick a point off of the terminal side, right? Okay. So what's the sign of the sine going to be? So what's the SIGN of the SIN to be? No, the denominator is what?
Positive.
Positive always. In the third quadrant, what's the numerator going to be?
Negative.
Negative, right? Because y-axis is negative in the third quadrant, right? You're below x-axis. So sine here is negative. What about cosine?
Positive.
Negative also, right? Because the x value is also going to be negative third quadrant. So cosine also is negative. What about tangent though? Yeah, you have negative over negative, which cancels to give you what? Plus, right? Okay. So in the third quadrant there, tangent is positive. Oh, so I just mentioned this, and I kind of went through it kind of casually. Notice that for obtuse angles or negative angles, the trig ratios can be positive or negative, right? They can be positive or negative. They're not always positive. All right, now let's try actually calculating. Oh, well, this one we can do easily. Here's fourth quadrant, right? So same thing. What about the signs here for an angle in the fourth quadrant? Here's an angle in the fourth quadrant. I drew it negative, but you could also draw an angle in the fourth quadrant this way, right? Okay. So sine is what? The bottom is plus, the top is what? Minus, so you get negative, right? Cosine, bottom is plus, but the top is what? Also plus, right? Okay. Remember, cosine associated with the x-axis. So you get positive cosine. What about tangent here in the fourth quadrant? Well, let's see what y is negative, but the bottom is what? Positive. So altogether. Remember, I told you last time, may have forgotten it already, that tangent is always sine divided by cosine, right? Remember that tangent is sine divided by cosine. So if you know sine and cosine, you can compute the tangent. Well, notice here, since sine is negative and cosine is positive, that means tangent has to be negative, right? Okay. When sine is different from cosine, when sine has a different sign from cosine, tangent will be negative. Okay, now let's try to actually let's try to actually compute some, not just the signs, but let's compute some actual values here. Let's see how far we make it, because this is hard. And then I'm going to show you the shortcut, right? All right, so imagine you want to compute cosine of 135 degrees. Okay, so your calculator will do that very quickly. What does your calculator say, by the way, for cosine of 135 degrees? Make sure you're in degree mode. This is not 135 radians, so. .996, is that it, Ahmad? Is that what you're telling me?
I got negative 0.71.
Okay, negative 0.71. Yeah, that sounds better. Right. So approximately minus 0.71. All right, so let's see how that came about. How did the calculator end up with minus 0.71? Hopefully that out. All right, so here's a picture of 135 degrees. How far does that goes into the second quadrant, right? How far does that go into the second quadrant? What's this little tiny angle here? Yeah, that's 45 degrees, right? You're 45 degrees past 90 degrees, right? With 105. Okay, so all right, so there's our picture. We drew the angle. So the initial side here is along the x-axis. There's the terminal side. So now I have to pick a point off of the terminal side. Oh, I'm so lucky here though, because this terminal side is a 45-degree line, right? So what points over here in quadrant 2 does it pass through? What's this point going to be? See, this is a 45-degree line, right? So it has to go up at exactly a 45-degree angle. So what's the coordinates of that point going to be? And you'll see it. This is at x coordinate -1. So what must the y coordinate be? +1, because this has to be a 45-degree line, right? Okay. So there's -1, 1, there's -2, 2, there's -3, 3. Let's pick this one right there. So that must be what? -4 and what? 4, yeah. Okay. Otherwise, wouldn't have that 45-degree line if the X and Y coordinates didn't have the same magnitude. Okay, they don't have the same sign, but they've got to have the same absolute value. All right. So that makes it kind of easier, right? So what's the R here? Well, we don't even have to calculate the R, right? It's the square root of what? X squared plus Y squared, right? So it's the square root of minus 4 squared plus positive 4 squared, whatever that works out to be. And what's the top for computing the cosine? The X coordinate, right? It's the X coordinate. Remember, cosine associated with X axis. So you get minus 4 in the top. Let's see if we can simplify this. So this is minus 4 over the square root of, how much is that, 32? Now, can you simplify square root of 32 by hand? 32 is not a perfect square, so you can't simplify it completely. Can you simplify that a little bit? Can you write 32 as a perfect square times something? Well, you could write it as 4 times 8, and 4 is a perfect square, but there's a better choice. How else can you write it? As a product. Y'all don't understand what I'm asking you there?
4 and 2.
4 and 2? No, 4 times 2 is not 32, right? I want 32 written as a product. 8
16
and
and
4,
2.
but there's a better choice than that. 16 and 2, right. There you go. You can write 32 as 16 times 2. The reason I want to write it like that is 16 is a perfect square, right? What's its square root? 4. So you get 4 times the square root of 2. Now those divide out. So you get minus 1 over the square root of 2, which you can rewrite as minus the square root of 2 over 2. That looks familiar because the square root of 2 over 2 is the cosine of what other angle that we know? 45 degrees. Not surprising, right? Okay. The cosine of 135 is related to the cosine of 45 degrees, right? Right? Probably had to be, since 45 is a little bit past, it's 45 degrees past, I'm sorry, since 135 is 45 degrees past 90, right? So there it is, minus the square root of 2 over 2. Is that minus point? Is that what your calculator says? Is minus 0.71? I think so. Y'all compute the square root of 2 and divide it by 2. You're going to get about this, right? Minus 0.70. Okay, all right. So you see where that came from out of the pocket. Yeah, in the middle. Want the roll? Okay, all right, I'm going to pass the roll, and while we're doing that, we'll do another one. Okay. Gosh, I hope it's not something like 131 degrees, though, because that's going to be really. See how bad this one is. Man, this one looks terrible. 13 pi over 6. So it really helps to draw a picture here. Okay. It really helps to draw a picture. All right. So so there's already a skill which we've practiced. This is going to be on the test, though. It's in the angle measure homework too. Let's draw a picture of 13 pi over 6. So 13 pi over 6 is 12 pi over 6 plus another pi over 6. The reason I wrote it like this is how much is 12 pi over 6? That reduces to what? That reduces to 2 pi. And you know 2 pi is going to be just 1 revolution, right? So you can just take that 1 revolution out, you see, okay, already. And then how much do you have left after that 1 revolution? You got pi over 6. So this little piece right here is pi over 6. Let's see if that helps us. All right. So we go pi over 6 past 1 revolution, right? Okay. Now, so there's my picture. So there's my terminal side. It's in the first quadrant. So that kind of helps things, right? The terminal side ends up in the first quadrant. And now what do I have to do? Yeah, pick a point off the terminal side. That's what's hard now, okay, because this angle is pi over 6. All right, so here's what I'm going to do. Let's pick the point so we know what the x coordinate is. Okay. It's if this were 45 degrees, it would be easy to know what both coordinates is, right? But pi over 6, that's a trickier thing. I don't know what this line really looks like, right? Okay. So let's pick the point so we know what the x coordinate is. So I'm going to pick an x coordinate of 6, just for no good reason. If I draw that 1, 2, 3, 4, 5, 6, so over here. So I'm going to take this point where I know the x coordinate is 6. But of course, what I won't know exactly is what the y coordinate, right? So let me just fill it in there for the time being. Unfortunately, that's what I need, right? Okay, I need to know what the y coordinate is, right? Because that is part of the sine, right? Remember, sine is what? Y over the square root of x squared plus y squared, right? So darn it, I need to know that y coordinate there. Okay. But I have a little bit of a break because this right triangle that's in this picture, right? I have a right triangle in this picture. Oh, this angle in this right triangle is pi over 6. But I know some things already about pi over 6, right? Okay. So, and I know what this side is because I picked it out specially so that this side, right, the adjacent side would be what? 6, correct. So now we can figure out what this length is, can't we? Figure out what this length is, right? By using what? See, I'm trying to figure out this length, right, which is y in this picture, correct? It's the y coordinate of this point in this picture. But I know this angle is pi over 6. So I bet I can figure out this. This is like figuring out the height of that tree. Y'all did that just last time. What trig ratio can I write down here? Figure out this length. Yeah, cosine would be y over r, Ravi. Unfortunately, you're not going to know what r is, right? Tangent, there you go, right? Tangent of pi over 6 is in this picture what? Y over 6, there you go. But we know tangent of pi over 6. We calculated that already. That's in our table of special angles, right? What is the tangent of pi over 6? Now, pi over 6 is 30 degrees. You're right about that, right? Okay. But what's the tangent of 30 degrees? So you're just looking at your table. So what's the tangent? Square root of 3 over 3, is that it? Ah, yay. Okay. So we have just, is that right? Square root of 3 over 3? So we just have that equation left to solve, right? For y. Oh, okay. So let's do it. Let's cross multiply. So 3y is equal to 6 times the square root of 3. Is that right? So divide both sides by 3. What could be easier? 2 square root of 3. Is that it? Did I do that right? Ah, so we're done. Ravi, what's the sign? Oh, no, I'm sorry. I have to calculate r, right? So, but we can just fill those in. So we have what? The sign is going to be the y coordinate at this point, which is what? 2 square root of 3, right? Divided by the square root of, and now I have to square these things. So I get 6 squared plus 2 square root of 3 squared. So I get 2 times the square root of 3 over, what is this big number? 36 plus, what do you get when you square 2 square roots of 3? 12? So I get 2 times the square root of 3 over square root of 48 Hmm. Now, y'all help me simplify square root of 48. How can I write 48 as a perfect square times another number? What are the factors of 48? 2 times 24, but that's not very helpful. 12 and 4, not very helpful because 12 is not a perfect square. Well, I'm sorry, man. It's a little bit helpful. 4 is a perfect square, right? Okay, so that helps. 12 is not, so that doesn't help. But there's a better choice. What? Ah, there you go. 16 times 3, right? So I get the square root of 16 times 3, 2 square root. Wow, what is this coming out to be? So I get 2 square root of 3 over, you can extract the square root of 16, which is 4. These divide out, and oh, how nice, it's 1/2. Oh, finally, after all that, sine of pi over 13 pi over 6 is just 1/2. That's very, is that the same as sine of pi over 6? What's the sine of pi over 6? 1/2. Yeah, we could have seen that to start with, right? Okay, because if you draw pi over 6, correct? If you draw pi over 6, its terminal side is the same as 13 pi over 6, right? So they have the same, 13 pi over 6 and pi over 6 have the same terminal side. So all of their trig ratios have to be the same. So if you knew the sine of pi over 6, which we did, 1/2, we could have immediately deduced, oh yeah, that's got to be the same as the sine of 13 pi over 6, also 1/2. But now here we get it the fun way. Okay. Yes. If you could just look at, I'm not sure what you want to look at.
Instead of doing all of this, can I just
We could just see the pi over 6 and say what, Amanda? That. Okay, we are going to, we're, all right, so you have put your finger on a problem though, the one I already mentioned, and that is this scheme is kind of clumsy, right? Okay, because to calculate the trig ratios for angles, we have to be able to draw that terminal side, right? And what do we have to be able to find on the terminal side? A point. That's not always easy to do, right? Okay, it's not always easy to find a point on the terminal side, right? Okay, so we do have this issue of how do we simplify this process, because finding a point on the terminal side not always going to be an easy thing to do. Okay, so but we haven't gotten to simplifying the process yet. Okay, right. Okay. All right. So it should be clear to you, right, that when people are computing trig ratios, they're not going to go through this process every time, right? Okay, so there's got to be some way of doing it easier. Well, I'm going to let y'all do a couple then that are pretty easy. All right. So I want to know what's the sine of pi over 2. It's in your table. Okay, but that is not an acute angle. So where does that table get its value for sine of pi over 2? What does it say sine of pi over 2 is? 1, right? Okay, table says 1. Where does the 1 come from? Okay, and then cosine of 0. All right, cosine of 0 also is 1, isn't it? According to the table, where does that come from, right? Okay, so how did the table get those two numbers for sine of pi over 2 and cosine of 0? Now look, so what's the scheme? You're going to do what? Draw the draw the angle, right? Okay, the angle will include a terminal side, which is a line, right? And then you have to do what? Pick what off that terminal side? A point. Yeah, some point off of the terminal side. Now, guys, when you draw a 0-degree angle, what does that look like? It is a trick question because it's easy. Yeah, what does a 0-degree angle look like? It's just the x-axis, that's right. The terminal side is going to be laying on the x-axis, right? Okay, so the terminal side is the x-axis, right? The terminal side is also along the x-axis. So you have the initial side and the terminal side the same. Okay, see, the angle is flat, right? It's flat. So the terminal side is the x-axis in this case, all right? Of course, you know where the terminal side for pi over 2 is because that is 90 degrees, right? Pi over 2 is the same as 90. All right, so try drawing those, pick a point off the terminal side and see if you can calculate sine for me, cosine. You know what your answer is going to be, so if it doesn't come out to be correct, then it's back to the drawing board, right? You guys at home also, right? Okay, try drawing a picture of pi over 2. You see what the picture of 0 is. Pick a point and then use that point to compute those trig ratios, okay? Pick a point off of terminal. And this is that. Sine. That means sine y coordinate. Yeah, I know what we said. Yeah, the table it has one. Yeah, where's that one? Everybody came from. Square root. Oh, you're gonna- Don't know. So you just have. Oh, so draw that one. And then you just. That's the one. Slice, right?
Yeah, I think so that's.
But you have to.
So, yeah.
Why?
Already said
And I
this
think
is-
just
Yeah,
terminal side, y-axis, so pick a point.
that's-
Yeah.
Okay. Okay.
Squared. One, right. Okay, now try to do 0. It's just a flat. Now we get to 0 also. Once you've done the power to the 0, it's very similar. Right? Huh? No, that's not supposed to be right. Is that what's in the table? All right, so let's try doing this one now. So I need someone on Zoom here to help me with the first one, the C, right? Okay, so we want to draw that. We want to draw that pi over 2. So what does that look like? You guys at home, what does that look like? Someone at home, tell me what's pi over 2 look like when you draw that as angle. That's kind of hard to describe in words, but see what you can tell me so I can do it right. When I draw that, what is it going to look like? Ahmed.
Is it a 90-degree angle?
Yeah, 90-degree angle, right? That's a good way of saying it. So it's going to come up like this, right? Yeah. So there's pi over 2. So Ahmad, that means the terminal side is the y-axis, right? So all you have to do is pick a point off of the y-axis, any point off of the y-axis. So pick one for me, or which one did you use? What's a point off the y-axis up here? It's so easy, you're making it hard. Someone help Ahmad. What's a point off of the y-axis up there that he could use? 0 and 2, right here. Sure, right. Or you could have gone higher or lower. It doesn't matter. So the coordinates of this point are 0 and 2, right? You see, Ahmad? That's a point on the y-axis. Is that correct? Are you trying to answer me?
Yes, it is.
Yeah, right. That is a point on the y-axis. So once you've got that, then you're in business. Because remember the sign, I should have reminded you of what the sign formula was because it's scroll up there. So it's the y coordinate divided by, it's all, the sign is always associated with y, x squared plus y squared. So let's see, y is 2 in this point, and square root of 0 squared, that's the x, is 0 plus 2 squared. So you have 2 over square root of 4. But that's 2 over 2, right? Which is, voila, 1, correct? Which we knew it had to turn out to be, okay? At least according to the table. So that's why the sign of pi over 2 is 1, okay? What about cosine of 0? All right, Ahmad, so now you have to help me very quickly. We draw the angle. What does the angle look like? I've already drawn it here, right? Okay, there it is drawn. So it's flat, right? So the terminal side is really the x-axis for a 0-degree angle. The terminal side is the same as the x-axis. So so we just need a point off of the terminal side. So what's a point off the terminal side, Ahmad? Or anyone else who wants to chime in? So what'd you say, Amanda? I'll pick one that's easier for me to grab. 8's off my picture. Yeah. 4, okay. Azel says 2 again. All right, so that's good. That's good too, right? Any point will do, right? Any point will do. So there's 2 and 0. Okay, nice. So cosine, remember, is the x coordinate always divided by square root of x squared plus y squared. So cosine always associated with the x-axis, and so we get here 2 over, but the computation is very the same, right? 2 squared as the previous one. 2 squared plus 0 squared, so that's 2 over square root of 4. which of course reduces to 1, right? So cosine of 0 is 1, just like your table says. So remember, cosine of 0 is 1. Cosine begins at 1 and goes down. What's cosine of 90 degrees? What's cosine of pi over 2 according to the table? 0. So remember, cosine is decreasing at first. Cosine of 0 is 1. Then at pi over 2, it's decreased to 0. Sine goes the other direction. Sine starts at 0 and then increases to 1 at 90 degrees. Okay, so those two go in opposite directions, sine and cosine. Okay. Now, obviously, that's going to be a little bit cumbersome to be computing trig ratios always using this scheme. So we need to have a shortcut. And so I'm going to show you that's what I want to show you here. Eventually here is the shortcut. All right. So that's what we're aiming for now is our shortcut for computing trig ratios for angles that are not acute angles. Now, many times that shortcut will be to use the calculator. Okay. All right. But I'm going to show you formally how this process works. Okay. All right. What now? Acute. Yeah. So the trig functions for angles that are not acute have the same value except for the sine. Okay. As a corresponding trig function for acute angle. This acute angle is called a reference angle. So I'm going to show you how to find reference angles next time. A reference angle is what we use to compute trig ratios. That's our short. Okay. All right, but that's kind of a process. So we'll have to takes time to describe this process. All right, so we're going to stop there. Let's take about 8 or 9 minutes. So we'll come back at 11:45, and then I want to look at the sample test. Okay, some problems from the sample test, just to make sure that on easy problems you don't miss them making stupid mistakes. Because some of the problems are really easy, but you know, want you not to miss those easy ones. Just making a silly thought error. All right, so I'm going to pause the recording here for a minute. All right, let's resume here. Some things I want to remind you of about the test. So here's the sample test, and the solutions are posted, right? The solutions are already posted. Same place the sample tests are posted. So the solutions are there. Remember, the last part of the sample test we're not doing, so because that's trigonometry of right triangles. So you can see where if you look at the solutions to the sample test, it shows where we'll stop. It's right after those problems about arc length and circular sector, which is the end of this homework angle measure that we were just discussing earlier. That's due on Monday. Okay, so now one thing that sometimes those students thought off about a test that I'm giving here is, right? Oops, there we go. Right, is when when they have to answer questions like this that they have to write sentences, right, or a sentence to answer a question, and the answer is not a number or an expression. So in this problem, Marcus has bought a used car, and they're giving you some information about the value of that car. So it says after 1 year after purchase, it's worth $2,600, and then after 3 years, it's declined to $1,000, right? Okay, and then very important thing it says assume the resale value of the car decreases steadily as the lapse number of years increases. All right. So the very first question is about that sentence. It says, why are we justified in assuming the relationship between y and x in the problem is linear? That's important that we know that, because if we don't know that relationship is linear, we really cannot answer any of the other questions in the whole problem. Okay, but why are we justified in assuming that relationship is linear? Why do we know that? So what would we write here as our response to this, as and as close to a complete sentence as we could get? What's decreasing there? It's not just, it's a little bit more than that, Robbie. Robbie says we know that that the value of the car, the resale value of the car, is decreasing as X changes, as X increases, right? A steady rate, yeah, that's important. Okay, so so the answer here is we're justified because the resale value Y is decreasing at a steady rate. Okay, as X increases, all right, as the elapsed number of X increases, right, and that steady rate that gives away that this is a linear function. Okay, other types of functions will not have that property. Okay, and see, once we know that Y and X is linear, then we can write down a formula relating Y and X, right? Because we know what that formula is going to look like. It's like a formula for a straight line, and then we can answer all sorts of questions about the relationship between Y and X, right? So we're justified in this because the resale value is decreasing steadily. Okay, or the resale value is decreasing at a steady rate, right, as the elapsed number increases. So that's what we're looking for in the answer to that that first question. Now, once you know you have a linear relationship, right, then of course you can write down the formulas I just mentioned, and that involves computing the slope, right? So that's the very next question. Let's find the value of the slope and then explain what the slope is telling us. All right. So to find though the value of the slope, right, to use our slope formula, we need to know what. So what information do you need to compute slope? 2 points on the line, right? Okay, so see, these are the things that you're going to have to find yourself up, right? Or I'm sure that you figure when we take the test, right? Oh yeah, I need 2 points on the line. Now, those 2 points are not explicitly given to you, you know, as coordinates, but they're easy to deduce from the information you've got, right? So, what are 2 points on this? What are 2 points on this line? 1 in 2,600, right? When the elapsed time there is 1, right? 1 year after purchase, the resale value is 2,600. But 3 years after, it's gone down to 1,000, right? So see, you know, there are 2 points that are on the that are on that, and then you can use that to calculate the slope easily, right? So the slope is going to be what 2,600 minus 1,000 over. Let's make sure we do the subtraction in the same order. 1 minus 3. So I get 1,600 over -2, which is -8. Okay, so now easy to calculate the slope. And once you've got the slope, then you can write down the equation for the line really easy, right? By using point slope form. So you would have Y is equal to your slope, which is -800, X minus the X coordinate of one of your points, either one that you want here. Let's use the first one, plus the Y coordinate of that. So see, there's the equation for the, just that easy to write down the equation for the line. And once you have the formula for the line, then you can answer questions like D, right? Which is, you know, what's the resale value after 4 years? Just plug 4 into this formula. Or you can use your formula to find the y-intercept, right? Okay, of the line as well. So you can look at those things from the solutions. Now, the other question that's going to trip you, right? Because again, it's something that we have to write out in words is, you know, what is the interpretation of the slope in? Okay, so we calculated the slope, that's -800. What does that mean in words? What is that telling us? So we know the slope is -800, but what's the practical meaning of the -800 in the context of the problem? What is the -800 telling us? Yeah, that's kind of a geometric explanation of it, Amanda. But what's the practical in the context of the problem? Context of the problem is about resale value, right?
Yes.
Okay. Yeah, what is it?
Prices.
Yeah. Yeah, the resale value, right, or the price, that's fine. Resale value decreases because the slope is negative, right? By 800. Don't put -800 because you already said decreases, right? Now there's, you have to put a little bit more here. Decreases by 800 per year, right? Okay. So don't leave off the per or each year, you can say, or as 1 year goes by, you can say. There are lots of ways of saying that, but make sure that you put in the that for something. All right, let me see. All right, now this kind of problem where you're given information visually but not explicitly sometimes also trips up students. But you're familiar with the problem. It's asking you to find formulas for lines, right? So you know how to find formulas for lines, right? Okay, you have to know the slope and you have to know a point on the line, right? But what often confuses students is, you know, that information is not given to you explicitly. It's in this picture, so you have to deduce the information from the picture. You see, okay? So when you run across a problem like this, don't get intimidated by it. Just think about where's that information that I need. So if I want to write down the formula for this line L1, that's this line, okay? Then that's a line that's going uphill from left to right, right? I need to know its slope, right, to write down that formula. And to know its slope, I need to know 2 points on that line, correct? But do you know 2 points on this line? The line L1 here? Yeah, what are they? Yeah, it goes through the origin. So you know the coordinates of that point are 0, 0. And what did the coordinates of this point have to be? 3, 4, right? Right, because this distance is 3, this distance is 4. So the coordinates of that point have to be 3 and 4, right? And so now it's very easy to calculate the slope. What does that come out to be? 4/3? I'm going to write it down. 4 minus 0 over 3 minus 0. And now you can write down the formula for the line really easily, right? It's y equals that slope, 4/3, times x minus the x coordinate of one of your points. Why not use this one? Plus the y coordinate of that point. So you just end up with y equals 4/3 x. There's the equation for L1. Now, what about the equation for L2? Well, you need to know its slope, correct? Now, normally, to know its slope, you have to know 2 points on L2. Unfortunately, you don't know 2 points on L2, right? You know 1 point, it goes through this point, which is 3, 4, correct? But darn it, we don't know another. So we can't calculate the slope using the slope formula, but is there another way I can figure out what the slope is? Well, what do I know? L2 and L1 are perpendicular because they meet at a 90-degree angle, right? Okay, and we know the relationships of slopes and perpendiculars, right? So we do have the information we need. What's the slope of L2 going to be? Well, if this is 4/3, then this slope is going to be what? Negative 3/4, right? The negative reciprocal. And then you're done, right? Y is equal to minus 3/4, x minus, there's our only point, so our x coordinate is 3, plus y coordinate that point is 4. See, that would be such an easy problem on the test, right? Okay, but don't be intimidated because of the way the information is being presented to you. Okay, just look at the picture and think about it. All right, now here's a problem that students frequently miss, and so I do not want you to miss this. In particular, I'm talking about part B, where it says graph the lines. You need to, or plot the lines. You need to be able to graph lines, okay? All right, so on this problem, on this test, I mean, I give the same problem a lot because graphing lines is just a very basic skill, right? And I get lines going all over the place, okay? So don't miss this type of problem on this or any other test, okay? Graphing lines is easy, all right? Now, one line you already know the formula for, right? So you should be able to do that quickly by just plotting a couple of points on this line, right? Okay, so make yourself a little table here and find 2 points on this line and then just plot them and draw a line through them. You can find the 2 points, right, by picking x values and finding the matching y value, or going in reverse. Pick the y value and find the matching x value. If you let x be 0 here, what is y? this equation. 7. So there's one point, okay, right? And now to pick another point, pick another x value or pick a y value, doesn't matter. What if we let y be 0? Then what's x? I think it's 7/3. Is that right? Yeah, if y is 0, that drops out. You have 3x equals 7, divide both sides by 3, so you get x is 7/3, right? So see, there's another line. Now you've got 2 points, so it's really easy to plot. If you can find 0 and 7, that would be about right there. You have to read this one carefully. This is 6. I put it to 5. 0 and 7 is right there. And then 7/3 is 2 1/3. Here's 2. So 2 1/3 would be maybe really close right there. And then just, connect them with a line, right? Darn it. I'm just using OneNote. So and so try, of course, on paper, you'll be able to do that much nicer than I can, right? So there's that one. Now, we want also the line parallel to this one that contains the point 2, 3. So it's got to contain the point 2, 3 right there. Right there. But I want parallel to this line, right? So we have to remember that relationship between parallel lines. What is the relationship between parallel lines? They have the same slope. So let's find out what the slope of this line was. Do that by solving for y, right? Put it in slope intercept form. So bring the 3x over and you get y is equal to minus 3x plus 7. So Mill, what's the slope there? -3, easy, right? So we want a line with slope -3 that goes through this point. So that would be y equals minus 3x minus 2 plus 3. And now just try to plot that line. Okay, it's got to end up being parallel to this one. So when you draw them, you better get parallel lines. If you get lines that aren't parallel, then you've done something wrong. Let's see, I know it goes through the point. We already said it goes through the point 2, 3, right? So we just have to find one more point. How do you want to find that? Let x be 0. So if x is 0, what does that come out to be? 9? Oh, these lines are really close together, right? Oh, did I plot 2, 3 wrong? No, these lines have to be parallel, so I did something wrong because they cannot go through these 2 points, right? Because they won't be parallel. So I draw this one really, I probably drew this one really early. This is not a very good graph of this. I didn't plot these points very well. All right, but nevertheless, you can see, right, how to look on the answer sheet. It's probably plotted. Right? Anyway, you see, right, plotting lines is simple. All you have to do is get a couple of points on the line and then connect them with a straight line. Okay. Okay, so now here's one though that's tougher, right? Okay, so find the x coordinate of the 2 points on this line. Oh, same line again. 3x plus y equals 7 that are distance 5 from the point 1, 4. Okay. So I want the 2 points on this line, distance 5 from the point 1, 4. I wish I plotted that line better so I could draw the picture up, right? Okay. 2 points they have to be on this line, right? And they have to be this distance from this given point. This point apparently is not on that line. Okay. By the way, how can you check to see if a point is on a line? Plug it in, right? Okay. And if it doesn't satisfy the equation, then not on the line. Let's see, does that work here? Oh, no, it does work, right? So if I mess this one up, if I mixed, because if I plug in 1 and 4 there, right, that does turn out to be 7. So what did I do here? Uh-oh. Let's check our answers and see what. Let's check our answers and see what I have. So remember, the answers are posted right with the sample test. So there's the sample test in the Blackboard page, right? And there are the solutions. So I can see what mistake I made here. There's the graph of the, are those the same lines? Yeah, okay, so there's the graph. And let's see. Well, it would be better if this point were not on this line, okay? But it doesn't matter. You can still go through the solution of the problem the same. All right, it just makes the problem a little bit less interesting, unfortunately. All right, so so let's talk about how we would. So let's go back and talk about how we would quickly look at this one. Okay, so so again, I want points on that line, right? And they have to be distance 5 from the point 1, 4. Okay, all right. So those points that we're looking for, we don't know, correct? So we don't know the coordinates for the 2 points that we're looking for. So since you don't know their coordinates, you're just going to have to use variables for their. So that's really an important first step here, right? Okay. You don't know the 2 points that we're looking for, so I cannot write down their coordinates. So I'm just going to have to pick variables to represent those coordinates, right? So let's just call those 2 points, right? X1. All right, so trying to figure out what XY is going to be here, right? Now, however, we do have some information. We know we want that point XY to be at distance 5, right? Away from this point. So let's use our distance formula, correct? I mean, obviously, the wording here is screaming for the distance formula. So let's compute that distance from my unknown point XY, right, to the point 1, 4. So how do you do that? What does the distance formula look like? Remember what you do there? Square root of what? Yeah, you take the difference in the x coordinates, right? And what do you do with that? Square it, correct? Right? Okay. And then same thing with the y coordinates, right? And what do you do with that? Square it. Okay. So there's the distance from my unknown point that I'm looking for, right? Which actually going to end up at 2 of them, down to this point 1, 4. Now, however, this d is not unknown because what do I want this distance to be? 5, right? So the d you don't really need there, right? Because you know you want this distance to be. Oh, see, now we have an equation, right? Okay, so that's nice. We have an equation that may be solved. I like to do that in algebra, solve equations. But what's the problem with this equation, Bill, that I think it has 2 unknowns? So it's got 2 unknowns in it, and so, but I only have how many equations? 1. So darn it, I need another equation, right? Okay. But do I have another equation? look carefully. Yeah, 3x plus y equals 7, right? Staring us right in the face, right? See, we also know that 3x plus y is equal to 7, right? Now I have two equations with two unknowns. Now, how does that help me? Here's the trick that you always try to use, okay? Look, if you take, so you can do this in different ways, but the obvious way here is if you take the second equation and solve it for y, you get what? Y is equal to 7 minus 3x, right? And now in the first equation, then, you can get rid of the y, because you know what y is equal. So you get x minus 1 squared plus 7 minus 3x, because that's what y is, right? Minus 4 squared. Now, what about that first equation? How many unknowns does it have in it now? 1. And now you can try to solve that. 4x. See? Okay. That's how the second equation benefits you when you have two unknowns. All right, now now this is going to take a little bit of algebra to solve this. I'm not going to go through the solution, but it's on the you can see it on the sample test. Where would you start solving this, though? What's the first thing you would do? No, the first equation, right? 5 equals, ignore all this in the middle. That's all kind of superfluous now. You just have this equation, 5 equals to that square root, right? Where would you start solving that? What's the first thing you would do? Square both sides, right? Because you want to get rid of the, you see the square root is just going to be terrible, right? So you've got to get rid of the square root, and you can do that by squaring immediately both sides, okay? So at least you can get rid of the square root. So you would have 25 is equal to what's under the square root. Now that's still going to take some work, okay? But at least the square root is gone. Next step is try to square these things out, okay? And see what happens, all right? So you can follow those steps on the solution sheet, okay? All right, one more thing I want to show you is problems like this, okay? So I didn't put the answers here, I don't think. So you want to practice this, though. These are easy questions. It just says sketch the angle, right? Okay. So try to practice that before you come to take the test, drawing an angle. Okay. Some of those are given in degrees. Some of them are negative. Some are positive. Some are in radians. Okay. So try practicing drawing those angles. The only ones that are really tricky are minus 2.5 and minus 7, because those are given in what? Radians. And those are not special angles. So probably the easy way to draw that would be to convert it to degrees, so you can figure out what you're looking at here, right? Because who knows what minus 7 is in radians, right? Okay. So so practice with that. Don't skip that. And then also 15 and 16. Okay. These also involve drawing angles again. Okay. Except they have some instructions in it. Like for instance, in 16, it says, so here we have this big angle, 29 pi over 6. So that's a really big angle. And it says, find an angle that's less than 1 positive revolution, but is coterminal. That means they have the same terminal side as this angle, 29 pi over 6. So what you want to do is draw 29 pi over 6, and then see if you can find an angle that's less than 1 positive revolution that has the same terminal side, right? What is 29 pi over 6, though? Wow, how big is that? How much is 2 pi in 6? We just did that earlier, right? 2 pi is the same as how many pi over 6? 12. So see, that helps you because you can see how many revolutions you have in here, right? In 29 pi over 6, you have what? One revolution is 12 pi over 6. Then what would another revolution be? 24 pi over 6. So you have an extra what? 5 pi over 6. Oh, that's easier to figure out. 5 pi over 6 would take you right here into the, take you right there into the second quadrant. This little piece would be pi over 6 left. So what's an angle that has the same terminal side as 29 pi over 6, but is less than 1 revolution? It's this angle, right? Which was what? That was the 5 pi over 6. Just try to take out those extra revolutions. See? So in minus 574, see, that's got minus 360 already in it, which is 1 revolution, but not quite 2 revolutions, right? Okay. Same thing here. All right, so practice with, look at these answers too, right? Because these are really, should be fairly straightforward problems. You don't want to miss them just from not having practiced them, is my point. Okay, oh, we're totally out of time. All right, so we're gonna have to stop there. So I'll see y'all on Monday at 10 o'clock, A through M, people. And then I'll see the rest of you at 11:15, right? Okay. Don't forget about doing your homeworks.
Have a nice day.
Bye. All right, guys, I'm going to see y'all, all the Zoom people. See you on Monday in person, right?
Yeah, see you Monday.